So today's lesson is about taking your own measurements. And, this is a piece of basalt from the mountains in North Phoenix, hills, mountains, um, and they are labeled as being tertiary volcanics. During the KT extinction event, there were two rounds of planet-wide volcanism. The first one covered the planet with volcanic ash. The second one brought all of the secondary mineralization that we look for in minerals. That's how those minerals get there. They get brought up by molten rock. And here in Phoenix, there were big cracks in the ground, and the rock flowed out. The molten stuff flowed out, supposedly. That's what they tell us. And I don't know. I'm just finding the rocks on the ground, right? I don't know. But when I go up there and collect rocks, what I find is that these are, in fact, not quartz and feldspar and amphiboles and hornblende mica that make up granite. That's what we're told granite is, yes. What we have is basically AUPT. It is gold platinum alloy. And it's not a whole bunch of little crystals, it's one single crystal, and it's tetrahedral. Okay, what you're looking at here is a four-sided triangular sides, moss on, a little bit, and they make a tetrahedron. And the little things, the little dished out places are not gas bubbles. Molten rock doesn't have gas bubbles because the gas isn't there. The stuff forms at about real close to 2,000 degrees Celsius. And at which point any possible gases are absolutely incorporated in the molten rock. And I don't think there is any. That's not what those are. Those are hoppers. Those are dished out places on a crystal that's cubic, and it has face-centered cubic hexagonal symmetry. Okay? Cubic hexagonal means that if I look at it and it looks like a square, I can turn it and it'll look kind of hexagonal. This one has the symmetry, this three-sided symmetry, like this, see? And they're all even. Boom, boom, boom. It's an equilateral triangle. And this one may be kind of 1, 2, 3, and you come down here and it's got 1, 2, 3, 3 sides. So it's like two tetrahedrons joined together, and that's what you got this shape from. And if you go out there and look, they're all like this, man. And the little gas bubbles are not random at all. They line up they line up in perfect little rows and columns because they're part of the crystal structure. If they were random gas bubbles, they could not do that. If they were a bunch of little crystals of different things, it would not create cubic symmetry. And cubic symmetry is repeated over and over because what it is the three primary dimensions, x, y, and z, and that's what we have, x and y and z, or maybe you could say z and x and y. It doesn't matter. It's just a label. It's not the thing. It's just our label for understanding it and labeling it in our mathematics. And if you look real closely, of course, you'll see that it's very, very, very shiny metal. And if you look even closer, you find out that it's got cubic structure all the way down. Look at that. It's like little threads woven together. Of metal. And that metal is not a whole bunch of different metals. It's AuPt, gold platinum alloy. And they don't have metallic bonds. It's not a metallic metal, it's a covalent metal. That is, they join together, gold and platinum, because they're joining together at depth, at great, tremendous depths and heat and pressure. And so they don't establish metallic bonds, they establish much stronger bonds called covalent bonds. And those covalent bonds are doubled because the 13-atom unit cell has enough time to establish double covalent bonds in that tremendous pressure. And so if I try to scratch this with a diamond, for instance, boy, let me see if that one will do it. No, it won't. Okay, I have. Here's some diamonds. There's a whole bag of them. And I got some nice ones in here. Now I think I can find one more scratch it. Scratch a piece of metal anyway. Diamond ought to be able to scratch any kind of metal, right? This is really a diamond. Really, really. See how the light goes around the periphery? That's because of planes of cleavage. And if you look really close, other than the hemp seed oil all over it, you'll find that it does in fact have cubic symmetry. And you can see the lines of cleavage. Those are not like poor polishing. It's planes of cleavage in carbon, because carbon atoms are all the same size and they all line up with each other in perfect little rows and columns. Okay, so here we go. Now this has a coating on it, so I'm going to have to take it off before I go any further. Hang on. Okay, so here we go. We got some stuff that I took off with my little zooper. We got some diamonds here. And we're gonna clean this off a little bit. And you notice I'm kind of working on a polish on this, but it didn't take off any of the bumpy stuff at all. My little zoopers just kind of polished it up a little bit. Didn't change the shape at all. Okay. See if I can position that where I can actually make a scratch on it. And you can sort of see where I dragged it across there, and doesn't scratch it. You know, I'm gonna have to put my phone down for a second. Hold on. Okay, I'm gonna try this. Okay, I made a scratch on it. Look at that. Watch. When you wipe it off, there's nothing there. There's no scratch. What that was a little bit of the tip of my nice little blue diamond here. And I wore a little bit of my blue diamond off on my AUPT. Yeah, it's 10 on the Mohs scale of hardness, like a diamond. So I can machine this and use these little dished out places as a place for, let's see if I can do it. See if I had a diamond embedded in there. Now I have a diamond bearing like in a watch. And I can put something on this that goes round and round, or make this go round and round really, really fast with no heat problems, because see, I can drill right through this stone or cut it with a diamond saw, cut it with a hole saw to cut a big hole through it, and I can hold it in my hands at the same time and not use water. No water. Doesn't get hot. It's a superconductor for heat. Now the guy that cuts diamonds professionally showed me that, and I took him some of my diamonds, and he didn't think they were really diamonds, but he decided he'd try them, and they weren't diamonds, they were silicon carbide, which is also 10 on the Mohs scale of hardness, and forms right with carbon. As soon as the carbon starts coming out of the mix, it also starts pulling silicon out. Silicon by itself, not silicon dioxide, but by itself, has a very high melting point, like platinum. It's about like platinum, I think. 16, 15, something like that. Okay, anyway. What we've got is a metal here that is 10 on the Mohs scale of hardness, and I can hold it in my hand when I cut and polish it, and I don't use water. I don't use water. Don't need it. It doesn't cool, it doesn't heat up in my hand, it doesn't get hot, and it doesn't heat the machine tools I use because it carries the heat away like water does. One of the reasons for that is because in this AUPT, let's get some close up here. 10. Somewhere in here, and I might be able to. I'd probably have to develop. Anyway, I've got some picture close-ups of this, and there are little tiny diamonds spread throughout the metal because they form first, right? And so the metal gets carried upward a little more and starts cooling down, and the platinum precipitates out, and each time it precipitates, it cools. They're carrying the heat away, and they're storing the energy at that same compression and heat level that they are, 10 kilometers deep in the earth. Fault lines are about 55 kilometers deep, 50 kilometers deeper than the deepest kimberlite. Kimberlite is a surface phenomenon. Diamonds are not. Diamonds form in every fault line on Earth with AUPT. Every one of them. Not just a few. They are absolutely ubiquitous across the planet. And if you read books and you don't check, if you say, okay, I know what that is, I know enough about that that I don't have to check because I read it in a book. That's what I said for about 35 years of graduate work. 35 years I've been doing this. And it took me 34 of them to figure that out. I'm hoping to pass that little bit of information on to people so that that doesn't happen again. Do your own measurements. Don't believe what you read in books because they had to start with the information they had available. It's not necessarily correct.